So I'm going to be talking about Hardy-Weinberg equilibrium and problems that come along with Hardy-Weinberg. So Hardy-Weinberg stated that the allele frequencies in a population will remain constant unless acted upon by outside forces. So how do we keep equilibrium according to Hardy-Weinberg? These are the following 6 things you need in order to keep equilibrium according to him. No migration, no mutation, large populations, random mating, no natural selection, and equal viability and fertility. So why do we study Hardy-Weinberg? We study Hardy-Weinberg for the following 3 reasons. It allows us to determine when gene frequencies are changing and why they're changing. It's important in the study of diseases and where to focus the funding. So if in one population, the allele frequency for disease A is 0.7, however, the allele frequency for disease B is 0.3, you would focus on disease A for funding and studying for it because it has a higher frequency. And lastly, it's a baseline for evolution. So now I'll be looking at a sample question, but before I look at a question, we'll go over the symbols you need in order to attack a question. So the first 2 letters are P and Q, dominant allele and recessive allele. These are genotypic symbols, meaning that in a question you would look for like the dominant allele is 0.37 or something like that. And then there's P squared and Q squared, homozygous dominant and homozygous recessive. These 2 symbols are phenotypic, meaning when you're looking at a question, it would say something like the dominant color brown has a frequency of 0.37. And then lastly, there's 2PQ, heterozygous dominant. So now I'll be looking at an actual question. Brown fur coloring is dominant to gray fur coloring in mice. If you have 168 brown mice in a population of 200 mice, what is the number of mice that are A, homozygous dominant, B, heterozygous, C, homozygous recessive? So when you look at this question, most people want to say that P squared is 168 divided by 200. That is incorrect. You would first look at the recessive, because recessive is your best friend. That's what builds up everything. You wouldn't start with dominant because you don't have anything to look off of. So then you would minus 200 from 168 to get 32, and you would divide that by 200, getting you the frequency of 0.16. And since you want Q, you would square root that to get 0.40. And then if you want P, you would minus 1 point from 0.40 to get 0.60. And then you would square root that to get 0.36. Then you would go with the formula 2PQ to times 2 by 0.4 and 0.6 to get 0.48. Now you would going back to answering the question, the number of mice that are homozygous. So homozygous dominant. So you go with P squared, you times 0.36 by 200 mice to get your answer. For heterozygous, you would go with this 0.48 and times that by 200. For homozygous recessive, you times the Q squared 0.16 by 200 to get the number of mice that would have that trait. So that's the gist of how you would solve a sample question of a Hardy-Weinberg question. I hope this video helped, and thank you for listening.